So having talked about the network performance monitor, let's talk about another service that allows you to monitor your network within Azure, and that's called Network Watcher. So if you go into all services, again with the three lines, and you choose Network Watcher, you can see that the Network Watcher service enables you to monitor and diagnose conditions at a network scenario level. Now the interesting thing about Network Watcher is it does run at the regional level. So right away when you're inside a Network Watcher, we've got this overview that breaks it down by a region, and we can see all of the Azure regions that you have access to, and right now they're all set to disabled. So we can already get a clue on how we're going to enable Network Watcher depending on the regions that we're particularly interested in. So in order to have Network Watcher to be useful, let's start with having a virtual machine. We're going to monitor the network traffic to and from a virtual machine, but in order to do that, we need to create one. So I'm in the process of creating a brand new virtual machine in the central US region. So while that's going, let's go back to the Network Watcher. Remember, it's under All Services, Network Watcher. And what we need to do is we need to enable Network Watcher for this particular region. Okay, so let's go down here, and it's Central US region that I'm creating this virtual machine. So I want to enable Network Watcher for Central region. I click on the three dots, and it's starting to enable that. So that doesn't take very long. We can see Central US is now enabled, and the rest of them are all disabled. Now, one thing that we can do is we can look at the way that the traffic is traveling through this region over our own networks. So we're going over to the IP Flow Verify tool within Network Watcher. So it's under Network Watcher, IP Flow Verify. Now we're going to basically set up IP Flow Verify. You see that it verifies if a packet is allowed or denied to or from a virtual machine. So we can set up a packet here, the from address and the to address, all this stuff, and we can determine whether or not the packet is going to pass through our network security group settings, for instance. So let's go into our resource group. We've got our logic app resource group. The virtual machine that I just created is automatically selected, and there's only one network interface card, and so that's automatically selected too. Now I'm going to test the TCP protocol, and let's try outbound traffic. Okay, this is the IP address. It's already selected for this virtual machine. Let's try port 60,000 leaving the machine, and let's see if that machine can access Bing. Now Bing, we would have to know the IP address, but I'm going to enter this one, which is one of the servers for Bing, and port 80. Okay, so this is bing.com, port 80. So what we're doing is testing if traffic is allowed to flow from that virtual machine, exiting port 60,000 on that virtual machine, and then reaching port 80 of Bing. Okay, so let's check that's allowed. So it's going to take a few seconds. It says loading, and we'll see that it came back and said access allowed, because we have in the outbound rules of our network security group that all internet traffic is allowed out from those devices. If we were to modify the default network security group settings, we could block traffic and we should see access being denied. Now, if we were to reverse the traffic, let's say we want to check whether whether Bing.com can access our local machine, we would expect that the network security group default settings is to block all incoming traffic from the internet. So let's try, try accessing port 80. Okay. So we're going to see if the port 80 is open on our local virtual machine through the network security group settings. Give that a second. And you can see it says access denied because we have all inbound traffic denied, even to port 80. We can try 443. We can try all the different ports that we want to coming into that thing. It should all be blocked by our network security group settings. So one thing we can do then is we can go to our network security group and we can open up port 80 or open up port 443 and then come back to IP verify, and we would expect that the access would be allowed. So another tool that is used to debug networking issues is called a packet capture. Now, you might be familiar with packet capture software that you can install in various systems. Azure makes it pretty easy for you to install the packet capture extensions into your virtual machines and be able to actually trap packets that are coming in to be able to examine them later. So if we were to say add packet capture, we will choose our subscription resource group, the target virtual machine, and we have to give it a name. So call it packet. And where does that packet capture get stored? We can put it into a storage account. Would have to choose either one of our existing storage account or put it into the diagnostics storage account of the Logic app. How many bytes per packet we want to capture, how many bytes per session, how long we want to capture. The real trick, of course, is how you filter it, because you could capture every packet, and that would be perhaps a lot of data, and you're not going to perhaps get as much useful data as you would think. So let's say I want to capture traffic that is from my own IP address. This is my home IP address. We could also signify that it's only to this virtual machine, but since we are limiting it to the virtual machine, then this would capture traffic only on this IP address. And then we can say, well, I think we use asterisks. So this should, if I was to try to access that virtual machine from home, you're going to get packets captured, put into the storage account, and obviously you can do some sort of troubleshooting by accessing the packet logs from that storage account.